So in this equation, we're being asked to identify the reducing agent. So the reducing agent causes reduction. Reduction, if we remember oil rig, is gain of electrons. So if you are going to cause gain, you must be giving them up. Now, what I would do for this is I would put oxidation states on and see who is themselves being oxidized, whose oxidation state is increasing, because they will be the reducing agent. So I'm going to have a look. So if every potassium is +1 and every oxygen is -2, then I've got -14 from the oxygens, -12 if you add on the 2 for the potassium. So the 2 chromiums each must be +6. I'm going to look at the chromium on the other side. Now I'm not going to divide up the sulfate, I'm just going to think of the sulfate ion as a -2 ion, and I've got 3 of them. So that's -6, and then so I need +6, but spread out over 2 chromiums, so each one is +3. So chromium has reduced its number, therefore the chromium has been reduced. It's not the reducing agent, it has been reduced. So we need to find somebody that's been oxidized. So who looks like they might have changed in the other direction? I'm going to take a guess that it's not in the sulfuric acid, because if it was something to do with the sulfuric acid, which we know can act as an oxidizing agent from our group 7 knowledge, it would change its oxidation state. It would become like sulfur or hydrogen sulfide. So I'm going to take a guess it's inside this, probably the carbon. So I've got -2 4 times, that's -8. So 4 lots of -2 is -8. Each hydrogen is +1, so that's +2. So -8 plus 2 is -6. So each of these carbons is +3. So we've got +3 for the carbon. And then over here, each oxygen is -2. That's -4. So the carbon is +4. So the carbon is increasing its oxidation state. That means carbon is being oxidized. It means carbon is involved in the reducing agent. So there we go. We can select the ethane dioate ion as the reducing agent.